This is a solution to question 8 on January 2013's S1 paper. We've got something here happening repeatedly until a success occurs. So we're dealing with a geometric distribution, and we're told that the probability of success for Sandra is 0.1. And they're asking in part A, find the probability that the first time she succeeds is on her 5th attempt. So that's a probability that x equals 5, if we say that x follows a geometric distribution, p being 0.1. So that means we fail 4 times, and the probability of failing is 0.9, and we fail 4 times, and then we finally succeed. So that's the calculation that you need to do here. And if you're thinking from the formula, the probability that x equals r is 1 minus p to the r minus 1 times by p. And that's what we've got here. 1 minus p to this value take away 1 times by our p value. And if you work that out, it comes out to be 0.06561. That was part A. Part B says the first time she succeeds is after her 5th attempt. So the probability of x is greater than 5, where x is her first attempt. And that's the same as thinking the probability her first attempt is on attempt 6 or after. So the probability x is greater than or equal to 6. Well, the probability x is the probability x equals 6 is 5 failures and then a success. That's x equals 6. X equals 7, which would be the next one we would include here, is 6 failures and then a success. Then it would be x equals 8, the 8th time is her first success. So that would be 7 failures and then a success. And what we're doing is adding those up forever. It's a sum to infinity. And you should know that if you have a sum to infinity, then you can add those up with a formula which is what a over 1 minus r, where that a is the first term. Basically it's this sum here, 0.95 to the 0.9 to the power of 5 times 0.1. And r is what you're multiplying by each time. It's called the common ratio. And to get from this number to this number here, or that value to that value, I'm timesing by an extra 0.9. To get from here to here, again I'm timesing by an extra 0.9. So r is 0.9. So I've got 0.9 to the power of 5 times by 0.1. On the bottom I've got 0.1. So they disappear, and I'm left with 0.9 to the power of 5. And if you work that out as a decimal, you get 0.59049. Part C of the question, they're saying the second time she succeeds is before her fourth attempt. The second time she succeeds is before her 4th attempt. So she could either succeed and then succeed and not bother with a 3rd attempt, or she could have failed and then succeeded and then succeeded, or she could have succeeded, failed and succeeded. There are no other ways that she can succeed for the second time before her 1st attempt. So here, that's a success followed by a success. This is a failure followed by a success and a success. This is a success followed by a failure followed by a success. And if we work out all of those and then add those up, you will get the answer to that bit. And if you do that, add those all up, you get 0.028. Now we move on to part 2 of the question, which is introducing another person. So just as a recap, we had so far Sandra, whose success was 0.1. We're now being introduced to Jill, and Jill's success rate is 0.2. And what they're saying now is find the probability that the first person to hit the target is Sandra on her 2nd attempt. So Sandra has a go first of all and must fail, the probability 0.9. Then Jill has a go, but she's also got to fail at that point, which is 0.8, which is 1 minus that. Then Sandra has another go, and this time Sandra succeeds. So that was Sandra being the first person to hit the target on her second attempt. Fail by Sandra, fail by Jill, success by Sandra. And if you multiply those together, you get the answer of 0.072. And part B of the question is an extension, but it's talking about the 10th attempt. So we're going to have Sandra failing and Jill failing. And then they're going to be failing. Each person is going to fail 9 times. So that is going to happen 9 times. And then Sandra is going to have her first success. So what we have here is 0.9 times by 0.8. That happening 9 times. So I can put a power of 9 on there. And then that has to be times by 0.1. And if you work that out, you get 0.005199, which is the answer to that question.